Note, this video is part of a larger series on speed solving the FTO. Click the playlist link in the description to see the rest of the videos. It's finally time to cover one of the most dreaded parts of the solution, the last two centers. It's pretty universally agreed that nobody really likes this step, simply because most of the time it encompasses the most moves out of any step in the solution, with very few fancy finger tricks or ergonomics really possible. In this video, my goal is to try to make the step suck less and provide you with more solving options to help improve efficiency. So let's get started. For this part of the video, I will be using green and red as my two last center colors, just to make the contrast a little bit better. But keep in mind, if you're using center neutrality, these colors could be any two of the three equatorial colors. First and foremost, it must be stated, even though it may seem pretty obvious, that the last two centers, just like how the first center and second center differ from each other, these also differ from those two. It requires a different solution strategy to not only avoid breaking up the block, but also avoid breaking up the previous second center. The most notable difference is the fact that moves that we do effectively have to be undone most of the time to preserve the orientation and relative reference of the centers. Furthermore, as we do moves to try to build parts of the last two centers, there's this small trap from the previous second centers that we don't want to break apart. So we have to be a little bit extra careful in this step. Now, another difference with second center is the fact that these last two centers have to be built on their correct faces. So in my case, since this second center was blue, this is going to have to be green on the front, and this is going to have to be red on the top. So unlike before, you cannot blindly build large or small traps on any face that you like. It has to be on the correct face. And there are even more differences, but we'll go into these into more depth as we explore other things that we can learn from with these solutions. Alrighty, here's an example scrambled last two centers, and I'll use this one to demonstrate a technique called top center building. If you ever saw my beginner's tutorial on the FTO, you may remember that I showed how to build a large trap on the front face of the puzzle, and then also build a small trap relative to the front face to finish the front center effectively to complete this step. However, only doing it this way is limiting yourself. In reality, you could also choose to build your top center instead of your front center as a reference. Similar to center neutrality, this technique gives you more options and possibilities for easier cases and is therefore more efficient on average. So let's do an example of this. So in this case, we have red on top, this red pair, so we're going to build the red center on top. And I also have this gray-red edge pair right here. So I know that if I match this up on the left-hand side of this red-yellow edge, then I will have a correct color scheme and I'll have a large trap. So we can do this in 4 moves, like this. And here is our large trap, and we can go ahead and turn that into the middle slice layer to preserve it. What this means is that we are now building the small trapezoid also on this top center. But the important thing to notice here is that now all of our moves are going to have to be done on this front center here to adjust things. And so in order to actually complete this part, we now have to bring that center to the top here with an R wide move. This time, as you can see, our moves have to be R primes as the first move and R's as the second move, instead of the other way around with R, then U, then R prime. This is also more difficult to do because now we can't directly see what is here on this back side anymore. And therefore, building the small trap this time is going to require you to remember where pieces go on this back side as you start to do moves. So for example, completing this small trap solution, I would have to remember that this red triangle is going down here as I do it. And then completing it from here looks like this. Like I had said, this technique is very useful, but it can be a little bit tricky to get used to at first. It's almost like doing F2L pairs from the backside, and requires changing your perspective a little bit. So you'll definitely have to give it some practice first before you'll notice it clicking for you. Now I'd like to talk about some of the interesting parity properties that occur with these last few edge pieces that are useful to keep in mind, as they will help you make better decisions with what to build in your last two center solutions. So here's an example of a possible case we can see. So we have a large trap on this face, and it is the correct color. This is supposed to be red. But we also have a large trap on this front face too, and it's also its correct color. This is green. So the question is, which center do we go for? Well, as it turns out, one of these will actually lead to a dead end and be very bad, whilst the other one will lead to a very good case. How do we know this? Well, if we look at these two large traps, we may be able to see it. In this case, this one is a correct color scheme, but this one here is an incorrect color scheme. You should definitely know how to recognize if you have a correct color scheme or not. So, is that a coincidence here? If we have two large traps, is one going to be correct and the other incorrect? And the answer is actually yes. What we have here is these two edges, which are the same color, and this one is a different color. It's an edge that belonged on the other center. So in other words, whenever you have a case where you have a large trap on this face and the other edge doesn't belong, if this large trap is an incorrect color scheme on this face, then you are guaranteed on the other face for these other two edges to have a correct color scheme. Now the triangle in between those edges may not be solved. You may not have a large trap on the other side. However, if you have a situation where you have two large traps and you don't know which one to pick, if you have this scenario where you have these edges that just don't match on their sides, then one of the traps, and only one, will have a correct color scheme. If you're wondering why this is the case, it is due to parity and cycles on this puzzle. If you do an outer layer move, it's cycling only 3 edges, 3 corners, these 3 triangles, and those 3 triangles. It's all 3 cycles. So what that means is you can never have a 2 swap of pieces. It is impossible. So all of the permutations for the edges must be even permutations. So that means if you have a 2 swap somewhere, you must have another 2 swap somewhere else. And that is why when we have these 2 edges that don't match on their faces, then if one trap has an incorrect color scheme, the other one must be a correct color scheme. It's guaranteed by parity. Pretty cool, eh? So using this to our advantage, let's say we look at this front face and see, oh, we have this large trap done. Ah, but it's an incorrect color scheme. Oh, I see I also have this large trap on top. I know for sure it's going to be a correct color scheme based on that parity property. So therefore, I know to base my second center solution on this center. So we're going to go ahead and put that large trap into the middle slice layer to preserve it. And then we can finish the solution from there accordingly. And now both centers have a correct color scheme, which is what we want. Now, there is another scenario to watch out for as well. Suppose instead we have all of the edges matching on the faces like this. Then in this case, if one color scheme is incorrect, then the other one actually is also going to be incorrect. So that's only if all of the edges match on the face. Like we saw before, if we had just 2 edges that matched on the face, if one was incorrect, the other was guaranteed to be correct. So this now works opposite, so you have to be careful. So in a situation like this, to solve last 2 centers, we would first actually have to build a correct trap. So you can either choose to do the top or the front. In my case, I think the ergonomics for this top one is a little bit nicer. So we'll first build a correct large trap, as we can see, and then we can continue to finish from there. Alright, now I'll take this opportunity to go ahead and mention another thing that we can actually watch for as a look-ahead technique when we're doing last 2 centers. And that is for that small trapezoid, that last small trapezoid that we form and insert to complete them. Remember, once we have the large trap, these 2 edges are always going to be done. They are never going to be involved with the moves anymore. And we only have one more edge to worry about. So what we can think about is keeping track of what color that edge is. In this case, this is the red gray edge. In my case, this is an edge that would normally be on that last layer. And this is actually nice to know, because when we finish this small trap, we are guaranteed to be using that edge. And so therefore, as soon as this small trap goes in to complete this center, it's going to be oriented correctly. In my case, this was because this edge happened to belong on the last layer. But, you know, you might have a different edge. You might be using different edges for your large trap and your small trap. So in this case, I'm using this edge. So what that means is, since I recognize this particular edge piece, it would normally have to go right here. That's counterclockwise. So I know I'm going to have to twist this center counterclockwise to orient it correctly after I finish my last 2 centers. as you can see. Now you may be wondering, can we also track the edges on the other centerpiece as well? And it turns out we can. So in this case, this is kind of the opposite situation. Now we're doing regular center building. So again, I'm going to complete this last small trap. Now in the last step of this part right here, right before we put in the last green triangle and then insert the small trap, notice this edge right here. This is going to be part of the other center. This edge, when we do this move here to form the small trap, it's going to stay in the right layer, right? So as soon as we insert this small trap, it's still going to be there. So before we do those 3 moves to bring it in, and I see this edge right here, I know, oh, this one has to go here normally when the center is oriented, so that means this is going to be a clockwise twist. So I would recognize that, and then when I go into my small trap, I know immediately that this center needs to be oriented clockwise. And see, I was right. And for the other center, we can use the same trick that I showed just previously, where we look at the edge that we're using for that small trap to know how to orient this center. So effectively what we can do is know the orientation, or how to orient these last 2 centers, immediately after we complete them, every single time. It is extremely useful to know this orientation at the end, because this transitions into the last bottom triple step, and it's very helpful to make that transition a lot smoother and reduce look-ahead pause. So there's that for you. Alright, I will now take the time to go over all of the bad, or rather non-trivial cases for these last 2 centers that are best solved with algorithms. Really, these shouldn't be thought of as algorithms per se, but rather memorized recognition patterns. There are about a dozen of these split up into several different groups based on what they look like, and I will go through them right now. First, I'll go over the grouped center cases where the centers are solved, but they're not necessarily placed correctly in some way. And there are 3 of these. Here's the first one. As you can see, both of our centers are solved on their correct faces. However, the color schemes are incorrect. The sequence for this case is the following. We first form a large trap that's correct on this top face here. And then we complete the small trap using the front face. Here's the second case. We have both of the centers completed, however, they're completed on their wrong faces. Also here, the front center has an incorrect color scheme and the top center has a correct color scheme. So since the top center has the correct color scheme, we're going to place that on top. The sequence for this case is the following. We first take this pair and place it on the front. We then switch over to form a large trap with this pair and this pair. And then we can finish off the small trap very easily. Here is the same case, except this time it's the front center that has a correct color scheme and the top one is incorrect. This can be solved with a very similar approach, except we will do an R wide move to place now this center on top, and we can solve this with the conjugate sequence. Now I'll show some cases where we have swapped large trapezoids. That is, we have a large trap on both the front and the top center, as you can see here. However, they are placed on their wrong sides. For this one, we have correct color scheme on both of these traps. We orient both centers like this, so the traps are pointing directly towards each other, and effectively we have horizontal bars like this. The sequence for this is the following. We're first going to bring this edge up to the top face where it belongs. Then we're going to complete the large trap with this bar and this edge. And then we can finish the small trap very easily. And here's the other case where you have the 2 swapped traps, but now they have an incorrect color scheme, as you can see. This time we orient the centers like this, where we kind of have diagonal bars going this way. And the sequence for this is the following. We're first going to bring up this edge to form a large trap on top here. And then we finish off this small trapezoid solution. Next up are what I'm calling the checker cases, because they kind of look like a checkerboard on these faces. All the edges match on each face, but all the triangles are the opposite colors of that face. This first one is a pure checker case because the edges are on their correct faces, and this one has a correct color scheme on both of them. The sequence for this is the following. We're first going to form a large trap on the front center with these two green edges and a green triangle like so. And now we finish off this small trap solution. And here's the one where we have both color schemes incorrect. And this is solved with the following sequence. We first get a large trap now on the top face like this. And we then finish off this small trap solution. Now we have the two swapped checker cases. These are similar to before, except now the edges are on their wrong faces, as you can see. This particular case is where the top center is a correct color scheme and the front one is incorrect, as you can see. The sequence for this is the following. We're first going to form a large trap using these two edges and a triangle on the front face, which goes like this. And now we finish off the rest of the small trap solution. Here's the final checker case, which is the same as before, except this time it's the front center, which has a correct color scheme, and the top one is incorrect. For this is the same idea, except we'll do an R wide move to now put this on top, and then we simply do the conjugate solution. And now finally we have two standalone cases. For this first one we have just a single edge that is out on this front center right here. So this has the correct color scheme and we just need to insert this edge. The sequence for this is the following. We're simply going to set up into an easy small trap solution. And now here is the final tricky case that we can run into sometimes. For this one, it's a little bit harder to recognize this, but effectively what we have is an opposite edge and triangle on both of the centers here, as you can see. And both of these edge pairs that we have are an incorrect color scheme. The other cases that look similar to this but are slight variations are relatively easy to do because you can easily form a large trap and then go from there, but this one's a little bit trickier. The sequence for this is the following. We're actually going to form a large trap on the front face using this triangle, this edge, and this edge, like so. And now that we have that, we can finish off the small trap very easily. And that's it. Those should pretty much cover all the tricky cases that you'll find. Ultimately, I don't really recommend learning all of these algorithms at once. You can watch them slowly and see sort of intuitively how they're working. Although some of these, like I said, are kind of non-trivial to understand. But hopefully they will be helpful for some people to help optimize this last two centers step. So that's about it for last two centers. Not the prettiest step of the solution, but it's definitely helpful to know these things to help prepare yourself for difficult cases or to just have better look ahead and fluidity. That's it for this video. Be sure to check out the others through the playlist link in the description.